I'm just trying to download if it is possible, because there's a button of download also. So that's it. Now I'll share my screen. So is the screen visible? Materials and techniques for tear mending.
Yes, ma'am.
So we'll be talking about not just tear mending, but other treatments also if there are holes or some complete backing is required. But it will be covered in two sessions. So today we'll mainly focus on the material basically, which is used for tear mending. So, what all you should have in hand when you are you have to do paper conservation, especially the treatment part, the mending part or backing part. First of all, you should have an adhesive to do this job. And the main adhesives that we use generally are um, wheat starch paste, CMC, which is the sodium salt actually of carboxymethyl cellulose, and then methyl cellulose. Apart from this, we should have some solvent like water or ethanol. Mainly these two are used. Then some kind of material with which we'll do the mending. There are many tapes also commercially available in the market, and they're of different types. I'll be talking about them tomorrow, but today we'll be talking just about the kind of mending that is done in the conservation labs. And that is done by Japanese tissue paper. And apart from that Japanese tissue paper, which can be from even 2.5 GSM we have used. So 2.5 GSM to 5 GSM, that is the thickness. It is very thin. So that's why it's such a small value of GSM. The normal paper that you use for photocopying and in your registers and notebooks, etc., is around 70 GSM. So you can just imagine that this would be so thin. And apart from this paper, we'll also need paper-like material, which is actually non-woven polyester and a polyester film, which is mylar. You can see the pictures. I'll take. Oh, this one is Japanese tissue paper. The second one on the top right is the non-woven polyester. Though from a distance you'll feel that they are similar, but the non-woven polyester is more fabric-like, and you won't be able to tear it with simple hydration. That means if by applying little water. But Japanese tissue paper will dissolve, and you can tear it from that point where you have applied water. So there's a lot of difference between these two. And this non-woven polyester is basically to support the paper you are treating, even in wet treatment or while mending and all. So it is the main property of this is that it doesn't allow the adhesive to pass through it. So it is a sort of barrier. So if you are doing mending and you don't have to put the paper that you're mending directly on the table or some other surface, there should be this sort of barrier so that the paper doesn't get stuck to the table, wood, or some other surface wherever you're doing the treatment. So it will act like a release sheet, and the paper will have, we can say, protection from whatever surface you're treating it on. And then polyester film, the bottom right is a roll of plastic-like sheet. Two main brands that are producing conservation grade, this is also polyester, but it is a film. And the two main brands are Mylar or Melanix. Then a blotter, a thick blotter. This particular picture is of different maybe thicknesses of blotting paper. Then felt is also similar kind of material. It is used in furniture also, and to give that padding. So, and we have to just, if when we have to press something, we put felt, blotter or felt on top of that thing. And weights and brushes. These are the things that you'll need when you're doing mending. Apart from this, you might also need some other stuff like cellulose powder, which is not mentioned in these adhesives, and maybe some other solvent, and something else also. So we'll discuss all these things while um, in our next lectures and all, while demonstrating and all. And these are the basic material. First is wheat starch paste. It is a polysaccharide. It is maida paste basically. And I have seen myself in my family also making, when we were kids, maida paste to do the, to use it as a glue for pasting papers and all. And it is a more refined form of wheat. The particles are very small as compared to the thicker particles present in the wheat. So more refined particles from the wheat. And we also remove the gluten from it. And in tomorrow's, day after tomorrow's class, maybe I'll be able to discuss one of that methods also, how to remove the gluten, even from the maida, the refined form that we have. So we, at times we get extremely refined forms of this wheat flour, which is very white in color, even whiter than the normal maida we use in our kitchens. Now, I hope you can see on the right. Actually, I tried to make it for you to make a video, but I didn't get enough time, and because it is a 20 to 30 minutes process, and I thought I had pushed the start button of video, but it wasn't, and then I couldn't do it for 20 whole minutes, and I just left it, and I just clicked a little video of the later portion when the thing was being cooked. So when you have to make wheat starch paste, you'll take 3 parts water and 1 part wheat starch paste, and leave the mixture in a jar for at least 2 hours and shake it for a while. And then you have to cook it so that you don't get these lumps. So because I had not kept it for 2 hours, it wasn't done properly. So you can see little big bubbles over here. They're not exactly lumps, but they might form lump because you have to continuously stir it. Let me see if I can run this video for you. It's not working as was. So there are lumps, and you have to continuously stir it for 20-30 minutes to form a paste. So let me see. So it is getting thicker and thicker, and then again you have to push it through a sieve so that any lumps formed are also taken care of, they are removed. So then after it is cooked, you can put it in a bottle, glass bottle, and first you have to let it cool for some time and then put it in a glass bottle. And also what people do is, in conservation labs, is that they put some water over it so that a dry film is not formed, because it can be used for at least a week. And so this is another method of, so different labs have different methods. I've just mentioned 2 of these. In any case, you have to cook the this wheat starch, and this cooking process is better if it is done in a pan on a flame, but it can also be done in it can also be done in a microwave. there are different ways. So and we have some workshops where we try to make it in different with different techniques, different methods, and with a little different recipe, and then check the tackiness of each and every of those samples that we have created. So this is here we are taking 5 grams of wheat starch and pour in several ml of, we will take 150 ml of water, but put a little water in the wheat starch, 5 gram, and make a slurry. And rest of the water we boil, and then add this boiling water to the slurry and mix it quickly for 5 to 10 minutes. So then we will put it in a tray and let it cool. And if it is made correctly, this is the method where we'll uh, get gluten on the surface. So if we have done this thing correctly, a thin scum will be formed on the surface and we have to remove it. If no scum forms, we have to try this thing again, and we have to remove the scum from this. But for conservation labs, I'm again saying the same thing, that we do get extra refined forms of the wheat starch paste, which is even more fine than the maida we use in the kitchen. So you won't get any gluten in that. So you don't have to remove gluten from that, and you don't have to remove this scum. There won't be any scum formed in that case. So these are two methods, where one is where we are not discussing the scum. We are taking pure, extra pure wheat starch, and the one in which it is not that pure, and we might have to remove the scum formed in the process. Now here in this video, this is from the same video that I showed you yesterday. Yesterday I showed that portion where I was doing the aqueous cleaning. It is a very old video. So I'll also discuss, there are some changes, and over these years, conservators have found some things which are like better than what in this traditional way, and I'll discuss in between that also. And this is the next part of the same video where I'll be doing tear mending. So here I've taken the Japanese tissue paper with extra long fibers for the holding to hold. We don't cut this Japanese tissue paper with scissor. We always wet the area where we want to tear it, and it gets softened in that area. And I should have made a video for that also, how to cut the Japanese tissue paper with water. So we'll see that these fibers are, then it is not a clean cut like in a scissor, and these fibers are there because the Japanese tissue paper is made with long fibers and it has no grain. Now what is grain? Again, we'll discuss in the next class. And here I'm applying the wheat starch paste on the Japanese tissue paper on a glass slide. There are other ways also. You can do this thing on a mylar sheet also, on a piece of mylar, and then pick the Japanese tissue paper along with the mylar and put it, just turn it over the tear, and then you have to press it with the bone folder. This is a bone folder that I'm using, and I thought I'll bring it to show you also, but I don't think I've got it. Yeah, it's not here. So then I have put, I'll just repeat it again. I have put, this is the non-woven polyester, and blotter, thick blotter, and then a glass and weight. So I'll let it dry so that it doesn't has that wave. Now here there's another tear that I'll be mending, and here you'll see in the later part that here that I have taken a longer strip of Japanese tissue paper which is hanging out. Generally, it is done like that because we cut it then with the surgical blade along the edge. And uh, but some conservators have seen that if they already cut it from that area and just there's no hanging extra Japanese tissue paper which you have to cut later, then there is no curling. But any case in this also, I didn't find any curls or waviness in that area because of this extra portion of the Japanese tissue paper. But I have seen in some papers, some conservators have mentioned that if you don't take the extra thing and it is just edge exactly till the edge only, then there won't be any uh, curling or waviness caused because of that wetting in that area of the paper. So these are the various tears and edges that I'm mending with Japanese tissue paper and wheat starch paste, and I'm using the bone folder, pressing it, and then putting the non-woven polyester, then blotter, and because if you directly put a blotter, it will get stuck to it, and then you'll have a problem removing it. But if there is a Rime sheet or non-woven polyester, there are various brands and types, and Holitex, Rime, and we also have a different variety which is not exactly like this long fiber. This one is Rime, and it is called Bondina. So that can also be used instead of this kind of non-woven polyester, and it is a kind of barrier and it won't allow the adhesive to pass through and go to the blotter. So this is the result. Another thing that can be helpful in this video, one thing was that the length of the Japanese tissue paper. Another thing is that instead of doing it directly on the paper, you can do it on a light table, or this kind of this exactly you can see in this area. It's a table, wooden table, and on this I have kept this light pad, and it's a thin sheet, plastic kind of sheet, which lifts up. And if you have kept the paper on that, then the tears which were not visible to naked eye, they were not very obvious, though if you're carefully inspecting, you'll find them. They are more obvious, and because the light is passing through them. Because in this particular print, I was looking because I knew that I have seen a tear while making the condition report. But then when I took it on the table for tear mending, I couldn't find it, and then when I just put the sheet, light sheet, and beneath it, it was very clear. It came up very easily. So while doing tear mending and to looking for when we're looking for the holes and all, it's good if we have a transmitted light from the back of the paper. Now, the next adhesive that I would like to mention is we all use is CMC. Actually, it is sodium salt of CMC, carboxymethyl cellulose, and it is an anionic uh, cellulose derivative, and it is very polar adhesive, and as such makes a very good bond between sheets of paper and is useful for overall backings where stress on the bond is not real problem. Here, I would also like to mention that the other one that we'll be discussing apart from wheat starch paste is, I haven't mentioned it, okay, in this presentation, is methyl cellulose. So, which was there in the list, if you remember. So methyl cellulose is a good adhesive again, and in certain cases it is preferred because of its certain properties, because it doesn't dissolve in hot water, and if you have to give a hot water bath to that paper, you have to remove certain things which get off easily with warm water, then it would be preferred because it won't get dissolved in hot water. It will remain there. You can do that process of bathing even after that mending or temporary mending with methyl cellulose. But but you cannot give a complete backing. If you want to give a backing to a painting or a print, you cannot do with methyl cellulose. It doesn't form a good bond with the paper. So in that case, wheat starch paste or sodium CMC is good, and it gives a good bonding. And it can also be mixed with the wheat starch paste for these overall backing. And because it gives the starch paste, it provides it with a slip. The penetration into the paper fabric becomes better. So it is highly viscous. So another thing why CMC is good in giving backings to the paintings, if you want, there are many tears and you want to give a complete backing, uh, is that it can be given in a dry form. We'll see in tomorrow's day after tomorrow's class that when we are giving a backing, the paper has to be moistened, humidified, or made a little wet. And then the wheat starch paste is applied, or Japanese tissue paper with wheat starch paste is put on the back of the paper. And in that process, the paper is getting wet. Even if it wasn't done, it wasn't moistened earlier. But if the paper is, the media on the paper is sensitive and you don't want to wet it, uh, and you want to give a backing, it is badly torn. In that case, CMC is a good option because it is highly viscous, and in 2.5% solution of CMC is very viscous and not very wet, so that it can be brushed on the reverse of the original and the backing paper also, without either of them expanding too much or without much water penetrating the surface of the original. Though generally what we do, we don't put it on the original paper, but we put it on the Japanese tissue paper. So whatever the case, the paper won't expand too much. If it is wet with wheat starch paste, it will expand a little. But with the CMC, it won't expand that much. So you can put it on the back of the original paper in a dry state where it won't affect the original paper that much. So things that are incompatible with CMCR, that in acidic solutions it doesn't work, and also with the soluble salts of iron and some other metals such as aluminum, mercury, and zinc. So if there are some iron salts in the solution or aluminum salts or mercury or zinc salts, it won't work. So it is also incompatible with xanthan gum, and it may precipitate at a pH lower than 2, which is quite acidic. So I don't think that we'll have any situation where we'll be working at such a low pH. And when it is mixed with ethanol, again, it won't work properly. Now there are two more adhesives which I had not listed in the first slide, but I'm mentioning here because of their popular use in certain situations. One is hydroxypropyl cellulose, and it is commonly called HPC. And it is not only in paper conservation, it is also very helpful in textile conservation because it forms a thin film and which can be reactivated, we can make films of this NSL, and we can just put on the paper where we want consolidation or adhesion, or even on the textile, and just reactivate by just spraying the solvent in which it was made, that film was made. So this also we'll talk about in more details in the next class. And so in certain specific cases, special cases, uh, this particular adhesive is um, very helpful. It is non-ionic water-soluble cellulose ether with a remarkable combination of properties. Another one is ethyl hydroxyethyl cellulose. Um, Commonly, you can call it, I think the brand is Ethulose, the way it is available in the market. And again, this one is also very helpful in certain cases where maybe there is a lot of fungal growth, because it won't let fungus grow wherever it is applied, because wheat starch paste is quite prone to attack by fungi and bacterium and all. Even in CMC, we have seen that microorganisms grow. But if something is very vulnerable to this microbial growth, then this particular adhesive can be used. And it can be, I think, made in ethanol also, which is again, it sterilizes. Ethanol itself doesn't let the microbes grow. Uh, Here, I haven't given this, strangely, I missed the slide of methyl cellulose because I should have, and but I have talked about CMC. So we have to remember that neither CMC nor MC methyl cellulose alone are really strong enough to be used as adhesive when a great deal of stress on the bond is encountered, such as in tear repairs or hinges. So alone CMC is not that good. I can show you, because there are different schools of thought, and there are labs who are mainly using CMC only, not wheat starch paste. And there are many labs which use sweet starch paste only, and they are not interested in CMC and all. Um, and I have myself seen that when I repair a tear with CMC, the bonding is not that good. And if the same tear I mend again after removing CMC with starch paste, or mix these two, then the bond is good. And a nearly invisible tear mending is done. That means it is mended very nicely. So you can do and you can experience these things in a practical class. I think that is more important in conservation. Both methyl cellulose and CMC, MC and CMC are, they have good penetrating power. So they add this thing to the wheat starch. So if you add a little CMC or MC to the wheat starch, it will give a good bonding. But alone, they are not working that well, especially in the tear mending. So this I have already mentioned, that MC should not be used for an overall backing, as it is not a very popular adhesive, and as such will not affect very good bond between papers, especially smooth surface papers. And that's why I had not mentioned, I just started with wheat starch paste, CMC, and the two new ones, HPC and ethylose. So because it is not very popular, but yes, there are cases when this is required, especially when you have to give a hot water treatment to some paper object, then this is very helpful. So just a minute. So that's all for today's lecture. And I'll now take up questions, though we still have 15 minutes, but I don't want to start the meeting because I won't be able to complete. And I think it would be good if we just take up your questions regarding the tear mending process. Yes, you can unmute and ask the questions, or you can put it in the chat also. I can see the chat. Another thing I would like to do is, since we have time, I'll take this deionized water. And I'll take this. In the meantime, you can write the questions. I'll take this is carboxymethyl cellulose, sodium salt. And another thing, like in gels, some of the gels needed heat and some didn't. Similarly, here also wheat starch paste needs heat treatment, but this one doesn't. So you'll see that I'll put a little CMC in this. I should have had a glass rod to stir it, and initially it doesn't, lumps are formed, it won't dissolve. And but by the time we are discussing and I'm taking up your questions, in 5 or 10 minutes, it takes half an hour to 20 minutes to half an hour to completely dissolve. You can keep it overnight also. I have some CMC already made in my lab. But what we do is we just break these lumps, stir it for a while, and just keep it aside. And in some time, 20 minutes or so, even in 10-15 minutes that we have, you'll see that the particles will absorb water, they'll swell, and gluey thing is formed, which we use for mending, tear mending and all. So I'll just keep it aside. Yes, Ritvika is asking that are these mending techniques irreversible? Yes, because they're all water soluble. So with water we can reverse them, but you have to keep in mind that you should not do mending with this thought in mind that I can, if it goes wrong, then I'll do it again. They are reversible. They are reversible, but they should be reversed only if extremely important. So yes, they are reversible, but at times when the process has been too old, it has aged, it becomes a part of that paper, then it might get difficult also. And this is most of the conservators, they know this, so they always laugh about it. Yes, it is reversible. Yes, it is reversible theoretically and in practical ways also. uh, but we should not just do it in a rough way, thinking that okay, if it dries and it doesn't look good, then I'll do it again. So that should not be done. Any other question? Tripat, are you getting these things like about paper? Because you have already learned a bit of wall painting conservation, and this is something new for you. So, are you getting some of the concepts like how these things are done?
Yes, ma'am. I'm just absorbing like whatever you're saying for now.
Okay, so were you there since the first class, like condition reports and dry cleaning methods?
Yes, ma'am. I've been
Okay,
here.
right from the beginning. Okay, so I think it should be, you should be getting something, at least a rough idea about what paper conservation
Yes, yes,
is. Huh?
yes, ma'am.
And yes, Sanchita, have you done any tear mending or this sort of conservation in paper somewhere in your Dhiram or intact?
Yes, ma'am, I have done.
Mm-hmm.
But ma'am,
So
in that they have used starch paste,
starch based, yeah,
and
wheat
in
starch
Dhiram
based.
also they have used,
Yeah, mainly.
and in Dhiram also they have used the starch paste.
Okay. And how do you acquire that starch paste? Is it the extra refined one? I don't have right now. It is in the lab. It is Zen
Ma'am,
Shofu.
ma'am, I don't know. They have just used the maida, and पहले ma'am उन्होंने एक मसलिन क्लोथ में पानी में थोड़ा सा सॉफ्टन करवाया था, उसके बाद उन्होंने स्टोव पे उसको अच्छी तरह से स्टर करवाया था 15-20 मिनट्स तक।
Ma'am, in Dhahram, it was just a regular maida,
Maida
and
paste.
it was just regular maida, and by that they made a starch paste. And in one of the workshops, they did the tear mending thing with only CMC and Japanese tissue paper, and e- and while they were doing, it was so visible कि पता चल रहा है that okay, this is the tiered part and this is where they mended.
Acha,
So it wasn't perfect. So
okay.
it was 9 GSM tissue paper.
Oh,
So, and the paper was very thin.
okay. So,
Yeah.
so basically, in tear mending, the paper should be thin, not more than 5 GSM, and it is better if you mix these two things. Wheat starch, if you are using wheat starch paste, because the absorption is improved with CMC. MC and CMC are actually, they have good absorption power. So it is good for them. And bonding is also good with CMC. So to enhance the properties, and wheat starch paste, many labs, mainly in American labs, big national level or government, whatever labs, they used wheat starch paste only. And the problem is that in our conditions, uh, I have seen that it acquires fungal growth. Though they add some kind of antifungal, say orthophenylphenol or some sodium salt or sulfur compound, but um, still I've seen that it is affected by insect and microbes. So another thing is here, when we have time, I would like to mention is that if you have holes, there is another thing. Just a minute, let me bring it over here. We have this cellulose powder, and it is again white, like other powders, CMC and all. It is white powder. But for these holes and all, what we do is either leaf casting, there is leaf casting machine in some labs, and with paper pulp they are filled. But another technique is you have to cook this cellulose powder into different shades. Like you can cook it more to turn it into more brown or light brown or creamish, and you can keep these cooked cellulose powder and then add the CMC to it to form a paste. And you can use this paste to fill the small holes and all. And to match the color of the paper, you can use whatever different grades of cooked, degrees of cooked cellulose powder. So this is another thing that I wanted to mention here while and because if you try to retouch, if you are using a lighter paper pulp or something, it is always, you can always, someone can make out that this is some retouching. It is not a proper filling or mending. So any other question from you, Richard? I'm looking at the CMC. It's getting thick, but still you can see the lumps. But in half an hour or so, it will all be jelly-like, glue-like. Yes. No questions? So this time I'll be putting, because this is a new topic, yesterday I didn't put any quiz. And after this lesson, I'll be putting a quiz. And you can also ask me via emails and all. This is a really tough time. I always thought that in this, when we'll be doing these classes again in May, I'll talk about it. I hope everybody's safe. And Ritvika, are you in Delhi?
Yes, ma'am, in Delhi.
Are you staying, where are you staying, with some relatives or in some PG, or how? Or is it your home, like?
Breaking. Yeah, yes, I can see now.
Okay. So where are you staying, Bache? With your family? Is it your hometown, Delhi, or?
Yeah, no, ma'am, I'm staying with my family here.
Okay.
Yeah.
I hope everybody is safe. And
Surprisingly, they like my family. Actually, my mother had contracted the virus last year, so we had faced it last year,
okay.
and it was a bad one. But this time, touch wood, we have not faced it, but like everybody around us has and is still suffering. So it's a very weird
So have you
time
people
to
around?
just exist.
Do you have, hello? Do you have people around who have COVID or something?
Not in the house, but I think in the colony. I think all the houses around my house.
Oh.
Yeah,
And is it
and
taking too long to recover?
yes, ma'am. Last year, the doctors were saying, 14 to 15 days of quarantine period. But now, for this strain, doctors are giving a flat 21-day period for quarantine.
Oh. And Priya and Sanchita, is it okay at your place right now in Himachal, or are there
Yes,
cases
ma'am.
around? Acha, acha.
मैम थोड़े बहुत तो केसेस हैं मार्केट में.
Acha. So, and I
हाँ जी
hope
मैम.
you are wearing masks and taking precautions.
Yes मैम.
लॉकडाउन कब
Yes
तक
मैम.
का है आपका हिमाचल में?
मैम अभी तो 17th
मैम
बोला है,
17
बट आई डोंट नो.
17 बोला हुआ है ना?
मैम 17 तक का लॉक, और जितने भी एसेंशियल शॉप्स हैं वो सिर्फ 3 आवर्स के लिए खुलती हैं.
अच्छा
फ्रॉम 10 एक्सटेंड हो.
अच्छा अच्छा एक्सटेंड हो सकता
हाँ
है बिकॉज आर डिस्प्ले केस फॉर सोलन इज
हाँ हो
रेडी.
सकता है एक्सटेंड हो.
अच्छा अच्छा काफी प्रॉब्लम आ रही है बच्चे काम करने में भी. एवरीथिंग इज क्लोज्ड, वी आर नॉट गेटिंग मटेरियल एंड ऑल. तो लैब में भी जो काम हो रहा है एक्चुअली, एक तो मैं अकेले ही हूँ अभी कर रही,
यस मैम.
नोबडी इज कमिंग. अभी मैंने आशा और त्रिपत को मना किया है, और सो आई डोंट नो हाउ थिंग्स
हाँ
वुड
जी.
बी. एंड ठीक है. सारिका, हाउ आर यू फीलिंग नाउ आफ्टर वैक्सीनेशन?
मैम
हेलो.
हेलो.
हाँ जी
हाँ जी
सारिका,
मैम.
कैसी तबीयत है अब आपकी? यू गॉट वैक्सीनेटेड एंड यू हैड प्रॉब्लम्स आफ्टर दैट. स्वेलिंग वगैरह
मैम
कैसी है?
मैम अभी हाथ में मतलब स्वेलिंग है तो है, बट थोड़ा कम है और मतलब बेटर है अब पहले से ना.
अच्छा अच्छा
पहले से तो बहुत सही है, पहले से तो.
फीवर तो नहीं हुआ?
मैम उसी दिन हुआ था फीवर, और मेरा बताया था मैंने आपको, माइग्रेन वगैरह हुआ था उसी दिन. फीवर तो मतलब कम नहीं हुआ, फीवर इतना ज्यादा नहीं हुआ, मतलब जितना मेरे को हेडेक मतलब.
अच्छा. एंड आशा, आप लोग कैसे हो? आपके वहाँ पे कैसा है?
हेलो मैम.
हाँ जी आशा.
हाँ जी मैम, यहाँ पे ठीक है मैम. कल वैक्सीन लगाने जाना है.
कल जाना है? अच्छा अच्छा. आप सारी फैमिली जा रहे हो?
Yes, ma'am.
ओके, गुड, ऑल द बेस्ट.
हाँ, मम्मी और पापा ने पहले लगवा ली.
अच्छा. हाँ, कईयों को सिम्टम्स कुछ नहीं आ रहे, लेकिन कईयों को आ रहे हैं, सो यू हैव टू टेक केयर. So I hope Harry, your city is also okay. There is not much damage over there. Hello. Acha, maybe he's not there. So thank you all of you, bache.
Yeah, it's all well over here, and wish you all guys also take precautions, be safe,
Hanji, hanji.
keep in
Please,
touch, guys.
all of you, please take care. This is a tough time, and this new strain is really bad. So take care, and we'll meet day after tomorrow with some more stuff for mending and all, and these techniques. And
Thank
if
you, ma'am.
and if I have missed anything, please let me know in the mail so that I can include. Maybe it is already included in the next lesson, but if somehow I am missing it, I can include. So if you want to know something specific, you can let me know. Okay, Vijay, thank you.
Thank you, ma'am.
Thank you, ma'am.